Alright everyone, we're back. Page 7 of the notes. We're going to do example 2 and then move on to the next stuff. We are going through probability of an OR statement. So what's the probability of this or this happening? To do that, we utilize the addition rule, which was defined here. Alright, let's try some more examples. I'm also planning to post some other videos just showing working through a problem or two based on addition rule or multiplication rule or conditional probability, things like that. So look out for other videos where it just kind of highlights a specific example. Anyways, let's give this one a go. It says that 35% of all homeowners in a large town hire someone to maintain their yard, 12% of homeowners hire someone to clean their home, and 9% of homeowners hire someone to maintain both their yard and their home. So what is the probability of randomly selecting a homeowner who hires someone to maintain their yard or clean their home? I don't know about you, but I read these and it's a little confusing and overwhelming. What really helps me is to take the time to write out the rule. And once I've written it out, I am then just following my steps to finish out the problem. So again, what they're asking for is what's the probability that we select someone in this town who hires someone to maintain their yard or their home. So again, I'm thinking here, okay, if I were to have a Venn diagram, here's people that hire someone to maintain their yard. And then I've got a bubble for people that maintain their home. Is there any overlap? There is. They say that 9% of the folks hire someone to do both. Okay, so I'm going to find the probability by finding the probability of getting someone that hires somebody to maintain their yard. All right, that would be like this bubble. And then I'm going to add to that the probability of selecting someone that hires someone to maintain their home. So that's like being in this bubble. And then again, you can see what happens is I double counted everybody in that green sliver there. I counted them when I asked who hires someone to maintain the yard, and I counted them when I asked who hires someone to maintain their home. They got counted twice. So I then need to subtract the probability of selecting someone that does both yard and home. That way I remove that double counting. Once this rule is written, I'm basically home free because they gave me all these probabilities. What's the probability that someone hires someone to maintain their yard? Here it says 35% of all homeowners hire someone to maintain their yard. So this is 35% or 0.35. What's the probability that a homeowner hires someone to maintain their home? It says 12% of the homeowners hire someone to clean their home. So it's 12% or 0.12. And then I need to subtract out the probability that someone does both. It says 9% of homeowners do both. They have someone to maintain both their yard and their home. So minus 9%. So this was actually easy once I wrote out the rule. And again, for me, that's huge because to just jump from here to, oh, that's what it is, I think that's a big leap. Take the time to write out the rule, and you're giving yourself a set of directions to follow from then on. Anyways, these would add up to, if I'm doing it right, 0.38. There's a 38% chance you would pick someone that hires someone to maintain their yard or their home. What is the probability of randomly selecting a homeowner who neither hires someone to maintain their yard nor clean their home? This sounds like the complement. This sounds like not yard or home. The complement of that thing, right? Neither yard nor home. So because I know this probability, I don't really have to do anything fancy. I know that complementary events add up to 100%. The probability does, that is. So I know that the probability of getting someone that does not hire someone to maintain their yard or their home is simply 100% minus the probability that someone does hire those individuals. Right, we saw that complement rule, I don't know, a few pages back. And the reason I want to use the complement rule here is because we already just calculated that number out. So if you do that, that's 0.62. 62% of folks do not hire someone to clean their home or their yard. Nor their yard, not or. Okay. All right, let's see what's on the next page. Again, I know I go kind of quick through these, but I'm assuming you're going to pause and rewatch as needed. A very common way to ask probability questions is using a deck of cards. So just be ready for that. I think a better way is using a bucket of marbles or something, because not everyone plays cards or knows what the standard deck of cards looks like. And in fact, here they've got it wrong. So they've laid out all the cards. These are known as clubs. They're black. These are known as diamonds. They're not spades. These are diamonds. They're all red. I got my hearts that are all red. And these down here are the spades. All right, we've got cards numbered 2 through 10. These are the aces. And these are all known as the face cards. All right, the jack, queen, and the king. Okay, so they say out of a deck, and by the way, in a deck there's 52 cards. Right? There's 4 suits. There's 13 for each suit. 52 cards total. What is the probability of randomly choosing a heart or a queen? The probability of pulling a card out at random and it being a heart or a queen. All right. Again, it's an or statement. So I'm using the addition property or the addition rule. If I were to think about this in terms of a Venn diagram, I want to know where are my hearts at, where are the queens at, is there any overlap? There is. The queen of hearts would be an overlap. So let's take a look here. If I say where are all the hearts at, that's all the hearts. So the first thing I want to do is find out, okay, well, what's the probability of just getting a heart? And then I want to say, well, what's the probability of getting a queen? There's all the queens. So I'm going to add to that the probability of getting a queen. But do you notice the queen of hearts there got counted twice? Once when I asked where are the hearts, and again when I asked where are the queens. So the queen of heart got double counted. It's my probability is a little off here. I need to remove that double counting, the probability of getting a heart and a queen, or namely the queen of hearts. Okay, well, the probability of getting a heart, there's 13 hearts out of 52 cards, so 13 out of 52. The probability of getting a queen, there's 1 queen out of 52 cards. I'm sorry, let's try that again. There's 4 queens out of 52 cards. And the probability of getting a heart and a queen, or in other words, the queen of hearts, there's only 1 queen of hearts out of these 52 cards. So at the end of the day, that adds up to 16 over 52, which you could reduce or just get as a decimal, 0.308, I believe. So 30.8% of getting a heart or a queen. Let's try part B. It says, what is the probability of selecting a face card or an ace? So the probability of getting a face or an ace. Same idea. It's an or statement. So I'm going to add the 2 probabilities together and remove any double counting if needed. Let's think about this as a Venn diagram. I've got all my aces here. Okay, so that's where all the aces would go. I've got all my face cards here. Is there any overlap? Is there, in other words, when I draw the face card bubble, do I overlap it or not? I wouldn't. There are no face cards that are also an ace. So there's no overlap. In other words, there's not going to be any double counting. I'm not going to do any double counting in this scenario. So if I want the probability here, it's simply the probability of getting a face card plus the probability of getting an ace card. Well, the faces, there's a total of 12 face cards out of 52 cards. Aces, there's 4 ace cards out of 52 cards. This happens to again be 16 out of 52. Just so happens to be the same probability. But if you again see there was no need to write, I could have written minus the probability of a face and an ace. I could do that, but it's just that all of that would have been 0. Right? Let me get a different color. All of that would be 0. There is no overlap, so there's no intersection there. So there's just no need to write it. Okay, let me keep going through these examples here. I think we'll be able to finish this page and then probably pause. So this says employment data at a large company reveal that 72% of the workers are married and 44% are college graduates, and that half of the college graduates are married. What's the probability that a randomly chosen worker is married or a college graduate? Again, it's so confusing. You read these, and I don't know about you, but I'm not struck with the answer by any means. I have to write it out, and the writing it out gives me a set of steps to follow. So here I want the probability that someone is married or a college grad. Okay. You know what? I need more space. I'm going to write it down here. Sorry. Probability married or grad. All right. Well, it's an or statement, so I know that I've got two events. In this case, I believe there's some overlap, so I'm going to have to find the probability of one event happening, the probability they're married, plus the probability that they're a grad or a college graduate. And then let's see, is there any overlap? 72% of workers are married, 44% are college grads, and half of the grads are married. So yes, I then need to remove the probability that I select a worker that is married and a grad. Okay, well, the probability that someone picked is married, it says 72% of the workers are married, so there would be a 0.72 chance that I pick someone that's married. 44% are college grads, so the probability of getting someone that's a college grad is 0.44. Again, what happens though is I got married, college grads, there's some overlap. So when I said who's married, they raised their hand. When I said who's a college grad, they raised their hand. And this group of people raised their hand twice. Once for when I said who's married and once for when I said who's a college grad. I have to remove that double counting. So I need to subtract from this minus the probability that someone is married and a grad. Well, it says half of the graduates are married. Since 44% of the workforce are college graduates, half of that would be 22%. 0.22 is the number of those that are married. And so at the end of the day, I'm running out of space. This comes out to, if I add it all up right, 0.94 would be the probability of getting someone that's married or a college grad. Now here, what's the probability of selecting someone that is neither married nor a college grad? Again, that's complement. That's the probability of not married or grad. Well, if 94% of your workers are married or college graduates, then 6% are not, right? Or 1 minus 0.94 would be 0.06, would be the probability of those that are not married or a college grad. Got 1 minute. Let's see if I can do this last example. Real estate ads suggest that 64% of homes for sale have garages, 21% have swimming pools, and 17% have both features. What's the probability of randomly selecting a home that has a pool or a garage? Another or statement. I want the probability of a pool or garage. Again, it's confusing to me, so I just write it out. I know I've got some houses with a pool, I got some houses with a garage, and some have both, so there's overlap. I'm going to find the probability of being here, plus the probability of being here, and I'm going to be sure to remove the double counting that takes place. So I want the probability of a listing having a pool, plus the probability that they have a garage, But again, some of those homes said raised their hands both times, once for the pool question, once for the garage question, so I need to subtract the probability of getting someone that has both.